Okay, so in the previous lecture we had actually a very basic or introductory lecture on the air pollution and the cryosphere. So in the previous lectures we discussed different type of water that is there actually, and how they are stored in the earth surface, on the earth surface. And in these lectures we are going to discuss regional impact of air pollution on cryosphere. So if you just, when we talk about the regional scale, Arctic, Antarctic and Himalayan regions, these are the three very important regions where we find lots of snow and ice sheets, or especially if you see this Arctic regions, black carbon from Europe, Asia and North America, they significantly reduce the slow albedo. So I think now you have fair idea that how the black carbon affect or reduces the snow albedo, and it can contribute to the warming, as well as melting of the sea ice and permafrost release trapped methane, amplifying methane warming again, which leads to the positive positive feedback loop. And if you see in the Antarctic region, airborne pollutions mostly are transported from the Southern America, Africa and Australia, because of the proximity or closer to the source. These are very closer to the sources. Antarctic regions region is close to these sources, and then black carbon and industrial emission again accelerate ice sheet thinning. Okay. So the thick ice will not be formed because of this one. So in the previous one we talked about that, okay, when the snowing will be happening, when the black carbon are there, the size of the snow grains can be reduced. So when the snow grains size will reduce, so when you say the thickness, the number of the, so this black carbon and industrial emission again accelerate ice sheet thinning. So there are another very important terms here, thinning. So this is not the melting, this is different from the thinning, because when the ice or snow formation will happen, these black carbon particles are, if they are included, the snow grain size can be reduced itself. And when the snow grain size is reduced, this ice sheet that is formed will be, this will not be thick, it will be rather it will be thinner. So yeah, this is what the is impact that we talked about, positive and negative feedback loops. Himalayan region, the third one, is actually very important, and it's very important for Asia. This is also known as third pole. Okay, these are the, apart from the Arctic and Antarctic, this is also known as a third pole. And the Himalaya are highly vulnerable to the pollution from the South Asia. So this, for the South Asia, this is very important because this supply a lot of water. Third pole, this supply a lot of water to the south of lot of water to South Asia. Okay, so if this is actually disrupted, there will be a problem about how they can be if the Himalayan region is disturbed because of the pollution, if the Himalayan glaciers are melt, then there will be millions of people will be vulnerable to this one. So yeah, impact water availability and the billions people dependent on the water, glacier melt water. Black carbon and dust from, again dust from the either from the Thar desert and other locations, and agriculture activities, they, and diesel from the black carbon from the diesel emissions or petrol or industrial emissions, they reduce the albedo. So you will see these words very frequently. So just now remember, black carbon, any light absorbing species, when this is deposited on the snow surfaces, it will darken the surface. It will not only darken the surface, but it will also reduce the reflectivity, because the solar radiation will not be reflected back properly. If you just compare the Antarctic, if you see the Antarctic ice, some facts, the ice volume is actually like almost like 13 to 10 to the power 15 meter cube. This is the total ice volume actually, and it will, if you just convert it to the density, it will be like sometimes it will be like 25 into 10 to the power 18 kg. So you can imagine it's such a huge Antarctic ice, such a huge mass actually is there. and about 90% of the world's ice mass, and which is about actually like 90% of world's ice mass and 70% of the world's freshwater mass. So this is actually 90% of the ice mass that we see over the Earth or the on the Earth's surface. 90% is actually like is in the Antarctic ice itself. And if you just estimate the ice loss, this is actually like 100 into 10 to the power 12 kilogram per year. So the loss is becoming very important. So if you just calculate this one, 25 into 10 to the power 18 divided by 100 into 10 to the power 12. So you have 24, 14 and 18, 4. So 25 and then you have 10 to the power 4. So about like in this much years, about 25,000 years, this Antarctic, if it keep on accelerating with this rate, within say 25,000 years, the Antarctic ice will completely be gone. So although it is not the only process, there are many feedback mechanisms that are actually contributing. So we are really not sure that what is going to happen and how, because this is actually the loss rate can actually increase or depending on the global warming condition, that how we are going to, how the earth warms and how we are injecting more of industrial pollution in the atmosphere, and which are transported to the Antarctic. So if you just take this roughly estimates about 25,000 years, 10,000 years. So 250,000 years, this ice, Antarctic ice will be almost like gone. So yeah, 250,000 years. Although it is very big time for if you compare on the on a human life expectancy level, but then if you just compare on the geological scale, this epic era is very small, so not very big one. Ice covered area is actually like 13.7 into 10 to the power 6 kilometer square, and which is 98% of Antarctic's emerged area. So you can see the number. These numbers are very. You see the unit here. It is actually in the kilometer square. So this don't be confused here. So 1 kilometer square will be like 1 kilometer is 1000. So it will be 10 to the power 9 here. Okay. So this will be actually 19 point this one. So in the above you have 13. So roughly it will be like 98% of Antarctic's emerged area. Ice thickness average may be somewhere around 1 kilometer, 1.6 kilometer thick, but it can go up to 4 kilometers. You can see such a deep, if you just compare the depth of the ocean, it is also similar, similar. The highest peak is about 4892 meters, so about 4.9 kilometers. And Greenland ice, the ice volume is estimated to be almost like 3.3 into 10 to the power 15, and then if you just compare with this one, which is actually 10 to the power 13 to 10 to the power 15, so you have only one tenth of the Antarctic ice. So Greenland ice is almost like one tenth of the Antarctic ice, and the loss here is almost like the same scale. Okay, and then ice covered area is 1.8 into 10 to the power 6 kilometer square. Ice thickness is actually 1.6 kilometers, but it can go up to 2 kilometers in some places. It's not 2 kilometers, sorry, it will be about 3 kilometers. But if you say average Greenland surface height is about 2.3 kilometers, because if you see here 1.6 and 2, if you take the average, it will not be able to make it 2.3. So this number is actually wrong. So it is about 3 kilometers, or roughly in that way you can say. So you see the Antarctic and ice and Greenland ice, they are actually have a different volume, mass volume, as well as aerial coverage. This I talked about in the previous slides. So this is, you see the deposition of the snow. You can see here very clean snow, white, and then on the downside you can see the blackish kind of things. Although it doesn't look like blackish, it is actually of course picture. So but this is actually purely reflecting, and this imaginary it has been shown that how this will look like. So it will look like black. And I discussed when the black carbon falls on the snow and ice, it decreases the albedo, and this means by when it decreases the albedo, more sunlight is absorbed, and this leads to an increase in the melting of the glaciers. So this is this process we have already discussed, and this means if you see ice, this is actually at this place the solar radiation is coming, 100% solar radiation is coming, and out of this actually about 85% is reflected back. Okay, so alpha is like 85% or 0.85, but if you see the places where you don't have any snow, the reflectivity is only 7%. So the alpha value is only 0.7. You can see the differences here. At one place you have almost like 15% is reflected back, okay, 85% is reflected back, and the other hand here the reduction is so much actually, like you don't have any so you just remove the top cover of the planet, lots of reflective ice cooling albedo, this will be replaced by dark ocean warming. So you really don't have a reflective ocean glacier surface there. So this means the solar radiation will be absorbed, more of the solar radiation will be absorbed, and this means accelerated warming as well. So snow albedo feedback loop melting, if you just start with this one, when that it is deposited, black carbon or dust or brown carbon, I'm talking about the particulate light absorbing species, light absorbing carbonaceous aerosols. Note it is not actually light, I just put, let's say, light absorbing species, okay, so that make it clear, because dust is not light absorbing carbonaceous aerosols, dust is actually separate. So if it is deposited, what will happen? Alpha will decrease. So as this deposition increases, if you have increased deposition, this will lead to a decrease in the albedo, and when you have lowered albedo, this will have a more of increased in the absorbed sunlight. So more sunlight will be absorbed, and when you have more sunlight will be absorbed, this means you have a more faster melting of the sea ice. So this is what will happen. Okay, so it's not the one way mechanism. Accelerated melting will again lead to lower in the albedo, and lower albedo means increased more solar radiation. So this is a kind of a coupled loop that is there, and it will be affected. And then vanishing Arctic ice, what will happen? Arctic when you have as the reflective ice disappears, dark ocean will absorb more of the solar radiation. So what will happen? When it will absorb more the solar radiation, temperature of the atmospheric temperature will increase, and you have actually like an increased temperature rise, and then it will lead to Arctic sea ice will melt faster, and then you have a very less vanishing, you will have a kind of vanishing Arctic ice. So impact on the glaciers melting, it can actually affect our global sea level rise, so it can actually, the melting is so pronounced that, you remember which I told that 97% of water is in the water is in the ocean, okay, and this melting is so you can imagine that, okay, whatever the surface water is actually there because of this one, so you have an ocean and this water is already there. If you just melt some water, melted water, this can reach to an increase in the water level or the sea level. Sea level will rise actually, and when the sea level will rise, what will happen? The places which are very closer to the sea, they will be strongly affected, because the water will be coming to the land, and then land where the people are living, the household, they will be disturbed. Himalayan glaciers feed major rivers. This is another very important, Ganges and Brahmaputra, and this, therefore, if it actually glacier melting is faster, supply to the Ganga and Brahmaputra water will be more, and this fresh water availability will be affected. So, this of course, this will be increasing. So, you have more fresh water available for the people or the billions of the people in the South Asia, but at some point of time when this Himalayan glaciers are actually like melted, what will happen? You will not have any additional source of fresh water. So, this will directly affect the people that are living in this area in the South Asia. Then it also affects the biodiversity loss strongly. Polar ecosystem depends on the ice are disrupted. So, you have polar bear, I think, polar bear. These polar bears need a habitat of low temperature. They are habitat in low temperature, and when the temperature is high and ice is actually very much needed for them, and when they don't have the when they don't have the ice, they will not be actually. So, they at some point of time, if it keeps on continuing, we may see that all the polar bears are gone. It will also have social and economic and social impact, because loss of freshwater reservoirs will directly affect the agriculture and hydropower plants that are there in the South Asia. So, most of the time agriculture is either fed by the groundwater or by the supply from the rivers, and when you have loss of the fresh water, then the agriculture activity will be affected. Hydropower plants and many of the hydropower plants that are located in the Himalayas, they are fed by this fresh water, they will be affected. Coastal community will be threatened by the sea level rise. So, this is I discussed actually in just a few seconds back. So, some quantitative data: Arctic melting, black carbon reduces snow albedo by 50%. So, now you can imagine a situation, you remember this one, almost like 85% was the reflectivity, but if there is actually like 50%, so you can have like 40 to 45% albedo if these black carbon aerosols are deposited on the snow. Then Arctic sea ice has declined by 13% per decade. This is very huge. Okay, so this is a very high rate during the just last 3 or 4 decades. Antarctica, West Antarctic sheet has already lost about 100 gigaton of the ice. 1 gigaton is actually like mega, then giga, 10 to the power 9 tons. Okay. Surface darkening from the impurities is measurable even in the remote areas. So, most of those areas are actually called pristine areas. They are actually remote. There are not actually much habitat there, and there are not much industries there. But because of the increase in the industrial activities and the transport to these regions, species like black carbon, dust, of course dust is a natural source, but this one is actually increasing over these ones, and then you can see the surface darkening effect on this one. Himalayan glaciers are said to be retreated by 10 to 15% over the past 5 decades, and which is actually a very huge, although these numbers are very controversial. Sometimes some of the studies show some places that glaciers, because glacier dynamics is very different, at some places the glaciers may be accelerating melting, but at some places the glaciers may be formed, actually new glaciers may be formed. So, this is actually very different story altogether, but we are not going to dive details or and this debate that whether it is 10 to 15% or something less, but just yes, of course it is actually like very high. And then contribution of black carbon to the melting is expected to be calculated is actually like 25%, which is very huge. Mitigation strategies. So, we need to have like some global initiatives. Basically, we have to reduce the black carbon through cleaner energy, and then of course, because if in the previous slides also I discussed, if you just reduce the black carbon, it will not only affect the the human health and the air quality as well as the atmospheric heating. If you just reduce this black carbon, this will be actually really very good for the glaciers. Okay, this for the glaciers health. So therefore we need to have a strict regulation on the industrial emissions. Okay, so industries, and then of course vehicular emissions contribute a lot, so industrial and vehicular emission has to be controlled. Then on the regional effects, like reforestation to minimize dust transport. We already have a deforestation, so this means many of the places the plants are cut, trees are cut. So when we have actually very reduced number of forest, so the forest area or forest cover decreases. When you have decrease in the forest cover and then intensity, the transport of the dust aerosols, if it is reduced, deforestation, transport of dust can increase, and this will be actually directly going and deposited to the glaciers. Sustainable agriculture practices to reduce biomass burning. This is also very important, because biomass burning is another important source of black carbon and then brown carbon as well. So if you just remove this one somehow or other, if you just reduce the biomass burning either from the agricultural waste or forest fires or any kind of garbage burning, this can lead to a reduction in the black carbon and brown carbon concentration in the atmosphere, and therefore they will have a reduced transport. Then scientific research, enhanced monitoring of pollutant deposition on the glaciers. There are actually huge research that is going on, especially in China. We are lagging behind in cryospheric research, and in fact we don't have much monitoring stations in the Himalayan itself. So this has to be enhanced, and one of the way to enhance is actually to bring new young students in this area which can contribute to the research for this research. So if they contribute, they will come, so there will be a good chance of coming into this one. This is another word of research in a cryosphere, and there could be a lot of research activities, and then lots of opportunities will be there in this one. Then there are actually like advanced climate models which have been used to predict future impacts. So lots of research has been going on. I'll just give you some of the case studies. So the best one is actually like this Flanner. They are actually one of the pioneered in this deposition research. You can just read some of these papers. So if you want to read the Arctic, Antarctic and the Himalayas, soot from the industrial activities has caused earlier spring snow melt by several days. Okay, in the Antarctic stations in the Arctic Peninsula report increased surface melt linked to the particulate deposition. And then Himalayas, of course, because of the deposition of black carbon from India and China, they account for about 33% of reduction in the albedo in the Himalayan glaciers. So we don't need to actually kind of be sure. I mean, we don't need to be actually having a lots of data on this one. The concept is very simple, because if any glaciers you have deposition of the particles, light absorbing particles, okay, what will happen? This will absorb the solar radiation, and when they absorb the solar radiation, and when the surroundings are in the night time or other periods also, they will re-release the heat that is stored in the particulate form. So when the heat is restored, heat is actually released, it will what will that? The immediately ice sheets and then ice that is there, actually it will be affected. It will be actually like start melting. So melting in any way scientifically, if you are depositing lots of light absorbing particles and you are putting lots of debris there and impurities are created, they will lead to an increase in the melting certainly. And of course, how they do? They reduce the albedo, and by reducing the albedo they will lead to an increase in the melting process. And if you just want to see more details, you can just go to this one, 5th assessment report of IPCC. This is one of the international panel on climate change. They'll have lots of discussion on this one, and then there is a special report on global warming of 1.5 degrees centigrade, highlight black carbon's role in the snow albedo reduction and its implication for Arctic climate change. So already there are studies that are there. The only thing, as I discussed, that we have to contribute or we can contribute, we need to minimize the emissions. If the emissions are not minimized, the emissions of light absorbing particles, especially the black carbon, because black carbon is the one of the largest contributor for snow ice melting and this darkening of the surface. So if we are not able to maintain this one, they are going to actually strongly affect our glaciers. So when the glacier health is affected, the melting is affected, and not only that, the melting doesn't only limited to the release of water, it has a feedback mechanism, because it will the aerial coverage, the albedo can be actually reduced. So you can just imagine a situation that when there is no snow, what will happen? Although there is no snow in the Antarctic and ice and Himalayan glaciers, the snow albedo, which is mostly highly reflective, say 85 to 95%, because of this will not be actually, no more will be there. So if this is not there, what will happen? The glaciers, if there are no glaciers, then the radiation will not be reflected back to the atmosphere, and this means most of the radiations will be trapped within the atmosphere, and this will accelerate the heating of the atmosphere. So we will have a kind of global warming effects, that already we have global warming, but we have a further accelerated global warming. So I thank you for your patience listening in this talk, and I think you need to read more if you want to really do research on these topics. I think this is the great time to come to this field and contribute. In India, we have couple of institutions like NCOPR now it is called, National Center for Ocean and Polar Research, in Goa, very beautiful place, very beautiful lab. You can go there and just monitor this one. And there are ISRO also supports some of these projects, Indian Space Research Organization, so you can get funding from there. So that the couple of things are there. There are lots of other things that are coming, but unfortunately the research in this area is lagging. So we need to contribute more to the cryospheric research, especially not only these things I talked about. If you, for MSc and PhD students, these are the surfaces. They contain lots of cryoconites, which can contain lots of mercury in that one. So during the transport and during our research with our colleagues from China, we have found that yes, mercury is present in the significant amount there, and this mercury are mostly produced because of the coal burning emissions, whether in the brick kilns or the industrial emissions. And we did some kind of mercury isotopic studies, and we found that this contributes significantly to the mercury. South Asia is actually one of the most top contributors for mercury in these regions. So I think there is actually plenty of opportunities. You just need to read, understand, and come forward for this great opportunity to do cryospheric research. So thank you so much. See you in the next lecture. Till then, I have given some references. You can just go through some of the literatures and try to study these things. Thank you.